In Level 2, we will be learning to graph a logarithmic function, or we call those logs for short. And the graph of a log we will find by taking the inverse of an exponential function. So logs and exponential functions are inverses of each other, like we studied back in Unit 1. So before we graph our function f of x equals log of x, we're going to graph its inverse, the exponential function, which is f of x equals 10 to the x. Log of x is actually the same as log base 10 of x. A log always has a base, and if there's no base written in, it's assumed to be 10. So log of x, its inverse is 10 to the x. So let's make a quick table for 10 to the x power. We'll make some xy pairs, -1, 0, 1, 2. 10 to the -1 is 1/10. 10 to the 0 is 1. 10 to the first is 10. 10 to the second is 100. And let's go ahead and graph that just to recall what an exponential graph looks like. -1, 1/10, 0, 1, 1/10, and then 2 100 is not going to fit on the graph. This graph has a a horizontal asymptote at y equals 0, and it looks something like this. Okay, now the graph of f of x equals log of x is going to be the inverse of this, and remember that the inverse of a graph you can find by taking the xy pairs and switching them. So I'm going to just actually use two of the points, 0, 1, and 110, and we're going to switch the xy pairs. So 0, 1 is going to become 1, 0, and 110 is going to become 10, 1. And I'm going to plot those points. 1, 0 is right there. Over 10 up 1 is right there. And remember that we're reflecting our original exponential graph over the x equals y line, and the new graph is going to look like this. And this graph has a vertical asymptote on the y-axis, and the equation of that vertical asymptote is x equals 0. So that red graph is your graph f of x equals log of x. Remember that our blue one was f of x equals 10 to the x. So those are two inverses. The domain of this log function, if we think about, now we're looking at our red graph, the lowest to highest x value, its lowest x value it never has any negative x values. It's approaching the x-axis, so it's approaching 0, but it will never hit an x value of 0. So the domain is parentheses 0 to infinity. Now the range, it goes down forever, and it actually goes up forever too. It's increasing very slowly, but it will continue to increase forever. So the range of a log graph is -infinity to infinity. Next, we are going to graph another log function, ln of x. We call this natural log of x. And natural log of x is the same as a log with base e, so log base e of x. And it's the inverse of the exponential function g of x equals e to the x. So if you recall, a table for g of x equals e to the x, if we did some xy pairs, we always use 2 points when we graphed e to the x. We use the point 0, 1, because e to the 0 is 1, and 1 e, which is about 2.718. Now when we graph e to the x, remember we had a point 0, 1, and then over 1 up about 2.7, and the graph looked like this, and we had a horizontal asymptote at y equals 0. Now to graph the inverse of that function, which is going to be the natural log of x, we're going to take our 2 points and switch the xy pairs. So 0, 1 will switch to 1, 0. 1e will be e1. And so I plot these points. 1, 0 is right here. And e1, I go over about 2.7, up 1. And my graph will look like this. So that is the graph g of x equals natural log of x. Remember that this was the graph of e to the x. So they're inverses, and they are a reflection over the x equals y line. The domain of this function, and this should say g of x, and we're talking about our natural log function, so we're looking at the red graph. The domain, again, it never has negative x values. Its lowest x approaches 0, so 0 with a parenthesis to infinity, and the range, again, is negative infinity to infinity. The y values go down forever and up forever. And then it has a vertical asymptote, again, at x equals 0. The other thing we will be doing in level 2 is applying shifts to these log graphs. So just the side to side and up and down shifts. No reflections, stretches, shrinks, anything like that. Just the shifts. So like with all transformations, if you have a number that's added or subtracted on the inside by x, that is a horizontal shift. And it's always the opposite of what we would think. So a -1 might make us think we'd go in the negative direction to the left, but we don't. We go 1 to the right. So this is going to shift 1 unit to the right. So if we graph, remember that the original graph of log of x had a point at 1, 0, and then a point at 10, 1. We're moving both of those points 1 unit to the right. So, and I'm also going to be shifting my vertical asymptotes. Remember we had a vertical asymptote on the x-axis. I'm going to move everything over 1 unit to the right. So I'm going to erase my asymptote and my first point and move them over 1. So I'm going to have a point that's 2 over, so over 2, and I'm not shifting it up or down, and my asymptote is now at x equals 1. And then I also need to move my point from 10, 1 over 1, and it's going to be off the graph. Over here. And that would be the point 11, 1. And then the graph looks like this. Its domain, its lowest x value this time, since it's shifted over to the right, the lowest x is approaching an x value of 1. It will never hit 1, so it's a parenthesis 1 to infinity. The range is always going to be negative infinity to infinity for log graphs. In this next example, we are transforming the natural log of x graph. So if you recall, that graph had a vertical asymptote at 0, and it had a point at 1, 0, and then it had a point at E1, so about 2.71. And it looked like this. And we're shifting, again, it's a horizontal shift because we have something on the inside by the x. A plus 2, instead of going to the right, is a shift to the left. So we're going to shift this graph 2 units to the left. So I'm going to start by shifting my asymptote over to x equals -2. And then I'm going to move my graph, all my points, over 2 units. So let's go ahead and erase. And from my asymptote, I can go over 1 unit. And then from my asymptote, I can go over 2.7 and up 1. That's about there. And there's the graph. Shifted 2 units to the left. Now in our last example, we are shifting to the side and we are shifting up. So the -2 on the inside tells us to shift 2 units to the right. And the +3 on the outside affects the y values. That's a vertical shift. So 3 units up. Okay. So if we start with our vertical asymptote by shifting it 2 units to the right, I'm going to draw a vertical asymptote at x equals 2. And my next point, I would move from my asymptote, I would move over 1 right there. But I also need to move it up 3. So I'm going to go right 1 and move that point up 3 to right here. And then my next point from the asymptote would go over E, about 2.71, and then up 1 more from the point I drew. So that is going to be about right there. And there's my graph, shifted up 3 units and to the right 2 units. Now the domain of this graph is going to be, its lowest x approaches 2, so 2 to infinity. Its range is always -infinity to infinity. And I forgot to do domain and range of the last one. This one's -2 to infinity, and the range is -infinity to infinity.